Alright, buckle up, because something absolutely massive just happened in the AI world, and if you blinked, you might have missed it. On July 31st, 2026, DeepSeek quietly pushed an update to their API. No flashy keynote, no multi-million-dollar marketing campaign, just a changelog entry that said, essentially, hey, DeepSeek V4 Flash is now officially out of preview. And the AI community lost its collective mind within about 6 hours. Why? Because this isn't just an incremental update. This is DeepSeek taking a model that was already terrifyingly good and making it absurdly, almost offensively better at the one thing that matters most right now: agentic AI. The kind of AI that doesn't just answer your questions but actually does work for you. Writes code, runs terminal commands, orchestrates tools, builds entire repositories from scratch. And here's the kicker that makes this absolutely wild. They did it without changing a single parameter of the architecture. Same 284 billion total parameters. Same 13 billion active per token. Same mixture of experts design. They literally just redid the post-training. That's it. Same engine, completely different fuel mapping. And suddenly this thing is outperforming models that cost 50 to 100 times more. Let me put this in perspective for you. DeepSeek V4 Flash, at $2.80 per million output tokens, is now posting agent benchmark scores that are within spitting distance of Claude Opus 4.8, which costs over $3 per million output tokens. But the input pricing gap is even more insane. 14 cents per million input tokens for Flash versus 43.5 cents for Pro, and well over $1 for frontier closed models. Axios picked this up immediately, calling it another step toward the commoditization of AI development. And honestly, they're not wrong. What DeepSeek is doing here is fundamentally breaking the assumption that capability and cost have to scale together. You don't need to spend Opus money to get near Opus agent performance anymore. You need 14 cents. Caixin Global covered it from the Chinese tech ecosystem perspective, noting that this release positions DeepSeek as the dominant force in the open-weight agentic AI space. TechNode highlighted the implications for Chinese AI startups who can now build agent platforms at a fraction of previous costs. And SCMP pointed out that this is part of a broader pattern, where Chinese AI labs are no longer playing catch-up. They're setting the pace. So what exactly changed? What are the numbers? Why is the community losing its mind over arena rankings? And most importantly, should you be switching your entire AI stack to this thing? Let's break it all down. Benchmark by benchmark. Ranking by ranking, dollar by dollar. Before we get into the benchmarks and the rankings, you need to understand what DeepSeek V4 Flash actually is under the hood, because the architecture is genuinely fascinating and explains a lot about why this model punches so far above its weight class. DeepSeek V4 Flash is a mixture of experts model with 284 billion total parameters. But here's the critical detail. Only 13 billion parameters activate for any given token. That's less than 5% of the total model doing the actual computation. Think of it like having a company with 284 employees but only 13 show up to handle any specific task. The rest are on standby, specialized for different domains, ready to be called in when needed. Each MOE layer contains one shared expert, a generalist that always fires, plus 256 routed experts. Out of those 256, exactly 6 get selected per token. The routing mechanism uses a learned gating network, and interestingly, the first 3 MOE layers use hash routing instead of learned routing, which DeepSeek says improves training stability at scale. The attention mechanism is where things get really interesting. DeepSeek V4 introduces a hybrid attention system combining what they call compressed sparse attention, or CSA, and heavily compressed attention, or HCA. Without getting too deep into the math, CSA handles long-range dependencies efficiently by compressing the key-value cache, while HCA handles shorter-range attention with aggressive compression. Together, they enable that 1 million token context window, while keeping the KV cache to roughly 10% of what DeepSeek v3.2 required at the same context length. They also replace traditional residual connections with something called manifold-constrained hyperconnections, abbreviated MHC. These use an expansion factor of 4 and 20 Sinkhorn NOP iterations. The practical effect is better gradient flow during training and improved stability at depth, which matters when you're training on over 32 trillion tokens. Speaking of training, the model was pre-trained on more than 32 trillion tokens using the Muon optimizer. which is a relatively new optimization method that DeepSeek has been pioneering. Multi-token prediction depth is set to 1, meaning the model predicts the next token but also gets a supervisory signal for the token after that, improving training efficiency. The 0731 checkpoint, the one released on July 31st, also ships with what DeepSeek calls DSpark, which is essentially a speculative decoding module. A smaller draft model proposes a block of tokens, then the full 284 billion parameter model verifies them in a single forward pass. Accepted tokens are kept. The first rejection truncates the block. Rejection sampling preserves the exact output distribution of the base model, so you get speed without quality loss. In practice, this pushes throughput above 60 tokens per second on DeepSeek's own infrastructure. And perhaps most importantly for developers, the model natively supports the Responses API format and has been specifically adapted for codecs. No translation shim needed, no hacky wrappers. You point your codec-style agent harness directly at DeepSeek's API, and it just works. This is not an afterthought integration. This is DeepSeek saying, we want Flash to be the default backbone for coding agents. The model is MIT licensed, fully open weights, available on Hugging Face. You can self-host it if you have the hardware. Unsloth's dynamic GGUF quantizations put the lossless 8-bit build at 162 gigabytes and a 3-bit build at 103 gigabytes. Or you can just hit the API for pennies. Both paths are viable, which is rare for a model at this capability level. All right, let's get into the numbers, because this is where DeepSeek V4 Flash goes from impressive to holy crap, is this actually real? I'm going to walk you through every major benchmark, and I want you to keep in mind that this is a model with 13 billion active parameters, not 13 billion total active. The thing doing the actual work per token is smaller than Llama 370B. Let's start with the agent benchmarks, because that's the headline story. On Terminal Bench 2.1, which tests long horizon terminal and shell agent tasks, V4 Flash 0731 scores 82.7. For context, the previous preview version scored 61.8. That's a 20-point jump from a post-training update alone. V4 Pro Preview scored 72.1 on this same benchmark. Flash just leapfrogged Pro. On this benchmark, only Claude Opus 4.8 scores higher at 85.0, and GLM 5.2 comes in at 81.0. So Flash is sandwiched between Opus and GLM, but at a fraction of the cost. NL2 repo. Building a working repository from a natural language specification. Flash scores 54.2. The preview was at 39.4. V4 Pro Preview was at 38.5. GLM 5.2 hits 48.9. Opus 4.8 leads at 69.7. So Flash is solidly in second place among these models, ahead of Pro and GLM. CyberGym, which tests security and CTF-style agentic reasoning, Flash scores 76.7. Preview was 38.7. Pro was 52.7. This is a nearly 40-point improvement from post-training alone, and Flash is now within 6.4 points of Opus 4.8's 83.1. DeepSeek, Real-World Software Engineering Issue Resolution, Flash scores 54.4. The preview scored 7.3. Yes, 7.3. That's a 47-point jump. Pro was at 12.8. GLM 5.2 at 46.2. Opus at 58.0. Flash went from barely registering to being within 3.6 points of Opus. That is genuinely staggering. Toolathlon verified. Multi-tool orchestration under verification. Flash scores 70.3, up from 49.7 in preview. Pro was 55.9, GLM 5.2 at 59.9. Opus at 76.2. Again, Flash beats Pro and GLM decisively. Agent's last exam. Hard, open-ended agent reasoning. Flash scores 25.2 versus 15.8 for Preview, 16.5 for Pro, 23.8 for GLM 5.2, and 25.7 for Opus. Flash is within half a point of Opus 4.8 on the hardest agent benchmark available. Automation Bench Public. End-to-end workflow automation. Flash at 25.1 versus 10.8 Preview, 12.8 Pro, 12.9 GLM, 27.2 Opus. Flash doubles Pro and GLM, gets within 2.1 points of Opus. Now the coding benchmarks. SWE Bench verified. 79.0%. Live Code Bench, 91.6%. Codeforce's rating, 352, which is genuinely competitive with the best models. GPQA Diamond, 88.1%. These are not budget tier numbers. These are frontier tier numbers. On the Artificial Analysis Intelligence Index, the 0731 version scores 50, a 10-point jump over the previous Flash release. For reference, V4 Pro Max scores 52, and Claude Sonnet 4.6 Max is in a similar range. Flash at 284 billion parameters is sitting at the same intelligence level as models with 5 to 10 times the compute. And on DS Bench, DeepSeek's internal suites, full stack at 68.7, hard at 59.6. These aren't independently comparable, but they show internal confidence that Flash is production-ready for complex development workflows. The pattern here is unmistakable. Across 9 agent benchmarks, V4 Flash 0731 substantially exceeds V4 Pro Preview. Not marginally, substantially. On some benchmarks like DeepSeek, it's a 4 to 7 times improvement. And it does this at a price point that makes you question whether frontier model pricing is even justified anymore. If you want to know what the community actually thinks about a model, you don't look at vendor-published benchmarks. You look at the arena, and DeepSeek V4 Flash is absolutely tearing it up on LM Arena. Let's start with the front-end code arena, which is arguably the most competitive and closely watched coding arena right now. DeepSeek V4 Flash High. That's the high reasoning effort configuration. Just reshaped the Pareto frontier. Their score, 1586 points. That puts them at number 7 overall in the front-end code arena. But more importantly, it's number 3 among open models. The Arena team literally posted about this, saying Flash reshaped the Pareto frontier, which is their way of saying this model is doing things that previously required much larger or more expensive models. In the broader text arena, DeepSeek V4 Flash in thinking mode sits at number 10 among open models, and number 47 overall. Now, 47th overall might not sound like much until you realize there are 363 models tracked across the Arena ecosystem. Being in the top 13% of all models while being the cheapest option available is remarkable. And among open models specifically, top 10 is elite territory. For comparison, DeepSeek V4 Pro in thinking mode, the much larger, more expensive sibling, ranks number 3 among open models and number 14 overall. So Pro is still the stronger model in head-to-head human preference, but Flash is right there in the same conversation at a third of the cost. What's really interesting is the trajectory. When V4 first dropped in April 2026, V4 Pro thinking hit number 3 open model within 90 minutes of release. That was already the fastest community adoption of an open-weight model in Arena history. Now Flash is climbing rapidly, and the 0731 post-training update is accelerating that climb even further. On the WebDev AI leaderboard specifically, which tracks models on front-end web development tasks, including agentic coding workflows, DeepSeek V4 Flash High appears prominently. The Arena data shows significant improvements in logic-driven tasks, coding, and mathematical abilities compared to the previous version. One particularly telling data point from community testing, on the Aider coding benchmark, V4 Flash High achieves 71.6%. That's competitive with models that cost 10 times more. And here's something that doesn't get enough attention: the cost per point metric. According to analysis from Kilo.ai, DeepSeek V4 Flash's cost per benchmark point is roughly 30 times cheaper than Kimi K2.6 and 100 times cheaper than Claude Opus 4.7. 100 times. You can run the same benchmark suite for 1% of the cost and get comparable scores. That's not a marginal advantage. That's a paradigm shift. The Artificial Analysis Intelligence Index also confirms this positioning. V4 Flash at max effort scores 50, which places it at Claude Sonnet 4.6 max level intelligence. Running the full intelligence index costs just $113 for Flash, compared to $4,811 for Claude Opus 4.7. That's a 42-to-1 cost ratio for comparable intelligence scores. The economics simply don't support the old model of pay more, get more anymore. The leaderboard situation tells a clear story. DeepSeek V4 Flash isn't just competing, it's rewriting the rules of what's possible at its price point. And the community response has been overwhelmingly positive, with developers rapidly integrating it into their workflows and sharing results that consistently validate the benchmark numbers. If there's one feature that separates DeepSeek V4 from everything that came before, it's how the model handles multi-step agent workflows. And this is where V4 Flash 0731 truly becomes a game changer. Here's the problem with previous models, and I mean all of them, including DeepSeek V3.2. When you ran them in an agentic loop, they were stateless between tool calls. The model would search the web, get a result, then the next tool call started reasoning from scratch. It lost its chain of thought. For a 20-step pipeline, search, run code, query a database, synthesize results. Each new tool invocation wiped the reasoning context. The model had to rederive its entire plan every single step. DeepSeek V4 fundamentally changes this. Reasoning is now persistent across the full workflow. The model maintains its chain of thought from the first tool call to the last. A 20-step agent pipeline doesn't lose context halfway through. The model remembers what it was thinking, what it planned, what it already tried, and what it needs to do next. This is not a minor quality of life improvement. This is the difference between an agent that actually works and one that constantly backtracks and contradicts itself. And the 0731 post-training specifically optimized for this. The 3 reasoning effort levels, low, high, and max, give you fine-grained control. Low is fast, cheap, good for simple tasks. High balances speed and depth. Max is full deliberation, which is what DeepSeek used for all their published agent benchmark scores. Temperature 1.0, top PP 0.95. Those settings matter because agent scores are extremely sensitive to the harness configuration. The native responses API support is crucial here too. Previous integrations required a translation shim between chat completions format and responses style items. Now it's native. You build your agent loop, you point it at DeepSeek, and the model speaks your protocol directly. No middleware, no format conversion bugs, no unexpected token losses. The codex adaptation is equally significant. DeepSeek specifically tuned Flash for codex-style coding agents. If you're running an autonomous coding pipeline, the kind that reads an issue, explores the codebase, writes a fix, runs tests, and submits a PR, Flash is now optimized for exactly that workflow. The DS bench scores of 68.7 on full stack and 59.6 on hard aren't just numbers. They represent real coding agent performance in realistic development scenarios. Let me give you a concrete example of what this looks like in practice. Say you give Flash an issue from a real GitHub repository. In max reasoning mode, it reads the issue, explores the codebase using tool calls, maintains its reasoning about what the bug is and how to fix it across multiple file reads, writes the fix, runs the test suite, interprets failures, iterates, and produces a final solution, all while keeping its reasoning coherent and not losing track of its plan. The Terminal Bench 2.1 score of 82.7 reflects exactly this capability. Long horizon terminal tasks require the model to execute dozens of shell commands, interpret outputs, adjust course, and ultimately accomplish a complex goal. That's persistent reasoning in action. And Flash does it at a level that's within 2.3 points of Claude Opus 4.8. What's remarkable is that this persistent reasoning doesn't come at a latency or cost penalty. Because Flash only activates 13 billion parameters per token, inference is fast, over 60 tokens per second. And because the pricing is fixed at 14 cents input and 28 cents output per million tokens, running a complex 20-step agent loop costs pennies. A typical agent interaction might use 5,000 to 10,000 tokens. At Flash pricing, that's less than 1/10 of a cent per interaction. This is why the agentic AI community is so excited. It's not just that Flash is good, it's that Flash makes agentic AI economically viable at scale. You can run thousands of concurrent agent sessions without your infrastructure bill eating your entire budget. Let's talk money, because this is where DeepSeek V4 Flash goes from being a cool technical achievement to being an industry-reshaping force. The pricing is simple. 14 cents per million input tokens on a cache miss. $2.8 per million. Wait, no. $2.80. Let me be precise. 2,800ths of a dollar. So 0.028 PEM per million input tokens on a cache hit, and 28 cents per million output tokens. That's it. No tiers, no complexity. No peak hour surcharge is active yet, though one has been announced. Now let's put that in context. Claude Opus 4.6 costs approximately $15 per million input tokens and $75 per million output tokens. Claude Sonnet 4.6 is around $3 input and $15 output. GPT 5.4 is in a similar range. Even DeepSeek's own V4 Pro costs 43.5 cents input and 87 cents output per million tokens. Flash is roughly 90 times cheaper than Claude Opus 4.6 for output tokens. 90 times. For applications where Flash tier quality is sufficient, and as we've seen from the benchmarks, that's a lot of applications. You are saving over 90% of your API budget by switching. The cache hit pricing is particularly devastating for agent workloads. When you're running an agent that repeatedly accesses the same system prompt, the same codebase context, the same documentation, those tokens hit the cache. At $0.28 per millions, your effective input cost drops to almost nothing. For a support agent or document pipeline that reuses context heavily, your marginal cost per interaction approaches zero. Let's do some real math. MarkTech Post ran the numbers with a realistic workload. 50 million input tokens per month, 10 million output tokens per month, 60% cache hit rate. V4 Flash costs $5.68 per month. V4 Pro costs $17.51 per month. That's a 68% savings. And remember, Flash now beats Pro on agent benchmarks, so you're paying less and getting better agent performance. For a startup running a coding agent product with thousands of users, this difference is existential. At Flash pricing, you can support 2,500 concurrent connections. That's the concurrency limit. At Pro pricing, you get 500, 5 times the throughput at 1/3 the cost. The unit economics of building an AI product on Flash versus anything else are simply in a different universe. The Towards AI hands-on test made this visceral. The tester ran 20 real tasks across all 4 V4 configurations. V4 Flash won 7 of 20 outright. In 5 of those wins, Pro Max had spent 4.3 times more output tokens thinking out loud, and still produced an identical or worse answer. Flash answered in 800 tokens what Pro Max took 3,400 tokens to say. At API prices, that's the difference between $0.0 and $0.1 12 cents per query. 120x cost gap for the same solution. And here's the number that should keep executives at Frontier AI Labs awake at night. Running the full Artificial Analysis Intelligence Index costs $113 for Flash versus $4,811 for Claude Opus 4.7. 42 times cheaper for a model that scores within a few points on the intelligence scale. The cost per intelligence point ratio has fundamentally shifted. Lightning AI's analysis put it perfectly. For tasks where you can tolerate Flash tier quality, which covers the vast majority of production AI use cases, V4 Flash at 0.28 per million output tokens is nearly 90 times cheaper than Claude Opus 4.6, while still hitting 79% SWE bench verified and 91.6% live code bench. Those are not budget numbers. Those are production-ready, enterprise-grade numbers. The broader implication is what Axios called the commoditization of AI development. When a model this capable costs this little, the moat stops being the model. The moat becomes distribution, integration, user experience, domain expertise. The raw intelligence layer is becoming a commodity, and DeepSeek is the one selling it at commodity prices. Benchmarks are great, but they don't tell the whole story. So let's look at what happened when someone actually put DeepSeek V4 Flash through real-world paces. Towards AI engineer Chulung Nian ran a comprehensive test, all 4 V4 configurations, 20 real tasks, same prompts, same rubric, same scorer. 2 hours after the models hit Hugging Face, he had the harness running. The 4 configurations tested were V4 Pro Default Thinking, V4 Pro Max, V4 Flash, and V4 Flash Max. The expectation going in was obvious. The 1.6 trillion parameter Pro Max should sweep the table. It has 37 times more total parameters than Flash. It has nearly 4 times the active parameters. It should dominate. It didn't. V4 Flash, the cheap 284 billion parameter variant, with only 13 billion active, won 7 of 20 tasks outright. Not tied, won 7 tasks where it produced a better answer than Pro Max, which was burning 4.3 times more tokens to think about the same problem. 5 of those wins were coding problems. Think about that. The smaller, cheaper model produced better code than the flagship on more than half the coding tasks where it won. And it did so in 800 tokens, while Pro Max took 3,400 tokens to reach the same or worse conclusion. Where did Pro Max actually shine? 3 specific workload types. 1. Million token context codebase reasoning. On 3 long context retrieval tasks using 800,000 tokens of a real GitHub repository, Pro Max hit 3 out of 3, while Flash got 1 out of 3. That 97% needle and haystack number from the paper showed up in the wild for Pro, but Flash struggled with extreme context. 2. AMA-style mathematical proofs. Complex multi-step mathematical reasoning where Pro's additional capacity genuinely helped. 3. Highly complex agentic tool use chains with many dependencies. But here's the critical insight from the test. DeepSeek has cleanly bifurcated the workload. Flash is a haiku killer priced at 3.5% of Claude Haiku 4.5. Pro Max is an Opus tier reasoner priced at 2% of Opus 4.6. They're not competing with each other. They're serving different use cases. And Flash's use case covers the vast majority of production AI workloads. The tester noted one benchmark where Flash fell apart: tasks requiring extremely long multi-step reasoning with many interdependent constraints. For those, Pro Max is still necessary, but those tasks represent a small fraction of real-world AI usage. Another critical finding: the KV cache trick. DeepSeek V4's architecture reduces KV cache requirements to roughly 10% of v3.2 at 1 million tokens. In practical terms, this means you can maintain much larger context windows without running out of GPU memory. For self-hosters, this is huge. For API users, it means the 1 million token context window is actually usable, not just a spec sheet number. The community response has validated these findings. On Hacker News, the V4 release thread cleared 400 comments within 90 minutes. On Arena.ai, V4 Pro Thinking hit number 3 open model within the same time frame. Multiple independent testers have confirmed that Flash's agent performance matches or exceeds the benchmark numbers in real coding workflows. One particularly compelling data point from the Kilo.ai comparison. They tested Flash against Claude Opus 4.7 and Kimi K2.6 on a standardized benchmark. Flash's cost per point was 30 times cheaper than Kimi and 100 times cheaper than Opus. The absolute scores were lower, but the cost-adjusted performance was in a completely different league. The conclusion from real-world testing is clear. If you're building a product that needs reliable, fast, affordable AI for coding, agents, and general reasoning, DeepSeek V4 Flash isn't just a good option. For most use cases, it's the optimal option. The only question is whether your specific workload falls into the small category where Pro Max's extra capacity genuinely matters. Here's what makes the July 31st release so philosophically interesting for AI development. DeepSeek explicitly states that DeepSeek V4 Flash 0731 has the same model structure and size as DeepSeek V4 Flash Preview. Only the post-training was redone. No new pre-training, no architecture changes, no additional parameters, just a better post-training pass. And the results are not marginal. On DeepSeek, Flash went from 7.3 to 54.4. That's a 47-point improvement. On CyberGym, from 38.7 to 76.7, a 38-point jump. On Terminal Bench 2.1, from 61.8 to 82.7, over 20 points. On NL2 Repo, from 39.4 to 54.2. On Tulathlon, from 49.7 to 70.3. On Agent's Last Exam, from 15.8 to 25.2. On Automation Bench, from 10.8 to 25.1. Every single benchmark improved dramatically, some by 20 points, some by 40 points, one by nearly 50 points, all from post-training alone. What does this tell us? It tells us that the base model, the 284 billion parameter architecture trained on 32 trillion tokens, was already extremely capable. The bottleneck wasn't knowledge or reasoning ability. It was alignment. It was teaching the model how to behave as an agent, how to use tools effectively, how to maintain coherence across long interactions, how to format responses for downstream systems. Post-training is where you take a raw, knowledgeable model and shape it into a useful tool. And DeepSeek clearly invested heavily in a new post-training pipeline, specifically optimized for agentic behavior. The result is a model that doesn't just know things, it knows how to do things. The practical implications are significant. First, Latency and cost profiles remain stable. No parameter count change means no reason to expect different throughput or pricing, and indeed none was announced. Your infrastructure costs don't change. Second, your prompts may still shift behavior. Post-training changes tool calling style, refusal behavior, verbosity. If you have prompt brittle agent scaffolding, you need to rerun your evals. The model is the same size, but it behaves differently. Think of it like a software update. Same hardware, new firmware. Third, self-hosters with the preview weights are not automatically upgraded. This was an API-side update. The changelog doesn't announce new open weights for the 0731 version. Although given DeepSeek's track record, open weights will likely follow. But for now, the full benefit is API only. The broader lesson here is about the diminishing returns of scale versus the increasing returns of alignment. For years, the AI industry operated on the assumption that bigger models were better models, that you needed more parameters, more data, more compute to get better results. DeepSeek V4 Flash challenges that assumption directly. A 284 billion parameter model with excellent post-training can match or beat models with 5 to 10 times the parameters on the tasks that matter most. This has enormous implications for the industry. If capability is increasingly a function of post-training quality rather than raw scale, then the barrier to entry drops. You don't need a billion-dollar training run to compete. You need a good base model and excellent alignment. And DeepSeek has demonstrated mastery of both. It also explains why DeepSeek can iterate so quickly. They don't need to retrain from scratch every time. They can run a new post-training pass, evaluate it against their benchmarks, and ship it in days. The preview to GA timeline was compressed because the base model was already done. Only the finishing touches needed to change. For the AI research community, this is a wake-up call. The next frontier of capability gains may not come from bigger models. It may come from smarter post-training. And DeepSeek is currently writing the playbook on how to do that. If you're a developer building AI-powered products, the native codecs and responses API support in DeepSeek V4 Flash might actually be the most important feature. Not the benchmarks, not the pricing, the integration story. Here's why. The AI agent ecosystem is rapidly consolidating around two key interfaces. The Responses API, which provides a structured format for multi-turn agent interactions with built-in support for tool calls, file handling, and state management, and Codex, which has become the de facto standard for autonomous coding agents. Previously, if you wanted to use DeepSeek with a Codex-style harness, you needed a translation layer, a shim that converted between the chat completions format and the responses format. That shim was a source of bugs, latency, and lost information. Tool call arguments could get mangled. Multi-turn state could be lost. Error handling became a nightmare. With V4 Flash 0731, that shim is gone. The model natively speaks Responses API. You configure your agent harness, point it at DeepSeek's endpoint, and the model understands the protocol directly. No middleware, no format conversion, no unexpected behavior. The Codex adaptation goes further. DeepSeek didn't just make Flash compatible with Codex. They specifically tuned it for Codex workflows. The model understands coding agent patterns. It knows when to explore a code base versus when to write code. It knows how to interpret test failures and iterate. It knows how to format diffs and commit messages. These behaviors were explicitly trained into the post-training pass. The practical impact is enormous. If you're building a product like an AI code reviewer, an automated bug fixer, a code generation platform, or an autonomous development agent, you can now plug in DeepSeek V4 Flash and get production-quality agent behavior without building custom prompting infrastructure. The reasoning effort parameter gives you 3 levels of control. Low for fast, cheap responses where you just need a quick answer. High for balanced performance on most tasks, and max for full deliberation on complex problems. For agent work, DeepSeek recommends max with temperature 1.0 and top PB.95, which is exactly what they used for all published benchmark scores. The maximum recommended output is 384,000 tokens, which is more than enough for even the most complex coding tasks. And the 1 million token context window means you can feed entire codebases into the model without chunking or summarizing. For teams currently using Claude or GPT for their agent infrastructure, the migration path is straightforward. The API is OpenAI compatible. Your existing SDKs work. Your existing monitoring tools work. The main change is the model string. You keep calling DeepSeek V4 Flash, and you automatically get the latest version. No version pinning required unless you want it. The concurrency limit of 2,500 for Flash versus 500 for Pro is also significant for production deployments. If you're running a SaaS product with thousands of concurrent users hitting your agent endpoints, Flash gives you 5 times the headroom. Combined with the lower per token cost, this means you can serve more users at lower cost with better agent performance. The self-hosting path is also viable for teams with data sovereignty requirements. MIT license. Open weights on Hugging Face. VLLM-compatible serving. DeepSeek's own example runs it on a single 4EPS GB300 node. Unsloth's quantizations bring it down to 103 GB for 3-bit, making it accessible on high-end workstations. The developer experience story is complete. Fast inference, native agent protocols, cheap pricing, high concurrency, open weights, simple API. There's really no friction left in the adoption path. Let's zoom out for a moment and talk about what DeepSeek V4 Flash represents in the broader context of the global AI competition. Because this is not just a product release. It's a strategic statement. 6 months ago, the narrative was clear. American labs, OpenAI, Anthropic, Google, led the frontier. Chinese labs were catching up. Impressive, but always a step behind. DeepSeek R1 had surprised people, but the consensus was that sustained frontier leadership required American-scale compute and investment. That narrative is dead, and DeepSeek killed it. With V4 Pro scoring 52 on the Artificial Analysis Intelligence Index and V4 Flash scoring 50, DeepSeek has 2 models in the top tier of open-weight AI. V4 Pro is the #2 open-weights model globally, behind only Kimi K2.6. And Flash at 50 is at Claude Sonnet 4.6 level intelligence while being open and MIT licensed. The agentic performance is even more telling. V4 Pro leads all open-weight models on GDP Val AA with a score of 1554, ahead of Kimi K2.6 at 1484, GLM 5.1 at 1535, and Minimax M2.7 at 1514, and Flash at 1388 is competitive with all of them, while costing a fraction as much to run. From the Chinese tech ecosystem perspective, as covered by Caixin Global, this release cements DeepSeek's position as the leading Chinese AI lab for open-weight models. It's not just about national pride, it's about ecosystem building. When you release a model this good under MIT license, you create an entire ecosystem of downstream applications, fine-tunes, and integrations that build on your foundation. TechNode highlighted the startup implications. Chinese AI startups can now build agent platforms on Flash at costs that were previously impossible. The barrier to entry for building a competitive AI product in China has dropped dramatically. You don't need to train your own foundation model. You don't need to license an expensive American API. You just use Flash and build your differentiation on top. SCMP's coverage emphasized the geopolitical dimension. When Chinese labs release models that match or beat American frontier models at a fraction of the cost, it changes the calculus for every company and government deciding where to build their AI infrastructure. The assumption that you need American AI to get frontier performance is no longer valid. The export control angle is also relevant. American restrictions on chip exports to China were designed to slow Chinese AI development. And to be fair, they've had some impact on training scale. But DeepSeek's approach, architectural efficiency, sparse activation, clever post-training, has proven that you can achieve frontier-level performance without the most advanced hardware. 284 billion parameters with 13 billion active is not a brute force approach. It's an efficiency-first approach, and it works. The pricing strategy is also geopolitical. By pricing Flash at 14 cents per million input tokens, DeepSeek is making it economically irrational for most use cases to use American frontier APIs. If you're a startup in Southeast Asia, Africa, Latin America, or Europe, why would you pay Opus prices when Flash gives you comparable agent performance for pennies? The gravitational pull of the DeepSeek ecosystem grows stronger with every price comparison. This is the commoditization thesis playing out in real time. Intelligence is becoming cheap, abundant, accessible, and the lab that makes it cheapest and most accessible wins the ecosystem war. Right now, that lab is in Hangzhou, China. The implications for the next 2 years are profound. If Flash continues improving at this pace, and the 0731 post-training update suggests it will, We may see a world where the most capable AI agents run on open-weight Chinese models by default, not because they're the absolute best on every benchmark, but because they're good enough, fast enough, and cheap enough that the economics are overwhelming. So where does this go from here? What's next for DeepSeek? And what should you expect in the coming months? First, the elephant in the room, V4 Pro. The official V4 Pro release was not included in the July 31st update. DeepSeek explicitly stated that only Flash was upgraded, and V4 Pro is promised as soon as possible. Given that V4 Pro preview already exists and scores 52 on the Intelligence Index, the official release is likely a post-training optimization similar to what Flash received. When it drops, expect significant agent benchmark improvements. The fact that Flash now beats Pro preview on agent benchmarks while Pro remains in preview is telling. It suggests DeepSeek is prioritizing Flash as the immediate commercial product, while taking more time to perfect Pro. The strategy seems to be capture the market with Flash's unbeatable price-performance ratio, then release Pro as the premium tier for workloads that genuinely need it. The peak hour surcharge that's been announced but not yet activated is worth watching. If DeepSeek introduces variable pricing during peak demand, it could affect the economics for high-volume users. But given the current flat-rate structure and the already extremely low pricing, even a surcharge would likely keep Flash well below competitors. The open-weight situation is also evolving. The 0731 post-training update was API only. The weights on Hugging Face are still the previous version. However, DeepSeek's pattern has been to release weights after API stabilization. Given the MIT license and the community demand, expect updated weights within weeks. When that happens, the self-hosting community will go wild, quantized versions will proliferate, fine-tunes will explode, the ecosystem effect will multiply. On the technical roadmap, several threads are likely in progress. The DeepSeek harness, which was used to evaluate agent benchmarks but hasn't been publicly released, will probably ship soon. This will allow independent verification of the agent scores and give the community a standardized way to evaluate agent models. Multimodal capabilities are conspicuously absent. V4 is text in, text out. Given the industry trend toward multimodal models, it's likely that DeepSeek is working on vision and possibly audio capabilities for V4.5 or V5. But for now, Flash is purely a language model, and it excels at language tasks. The speculative decoding module, DSpark, is another area for optimization. Currently, it provides a speed boost, but future iterations could push throughput even higher. Combined with the already efficient MOE architecture, Flash could eventually hit 100+ tokens per second while maintaining quality. For developers planning their AI stack, the recommendation is clear. Start with Flash for everything. Use it for your agents, your coding tools, your RAG pipelines, your chatbots, your automation workflows. The 2,500 concurrency limit and sub-penny per interaction cost make it viable for virtually any scale. Only reach for Pro when you have a specific workload that genuinely requires the extra capacity. Extreme long context reasoning, complex mathematical proofs, or highly specialized domain tasks. The broader industry trajectory points toward a world where foundation models are commodities. The value shifts to the application layer, user experience, domain expertise, data flywheels, distribution. DeepSeek is accelerating that transition by making the foundation layer absurdly cheap and capable. And here's the final thought that keeps me up at night. If DeepSeek can improve Flash this dramatically with just a post-training update, imagine what they'll do with the next architecture. V5 is probably already in training, and if the pattern holds, it'll be even more efficient, even more capable, and even cheaper. The deflation in AI costs isn't slowing down, it's accelerating, and DeepSeek is the one pressing the accelerator.